In the last couple of sets of notes, we've been talking about intersecting chords. In this section, we are going to revisit tangents and secants and involve that with chords as well. All right, so in this case, let's kind of review for a minute what a tangent is. A tangent is a line or a segment that intersects a circle at exactly one point. So in this case, we see a tangent here. A secant is a segment or line that intersects a circle in 2 points. So here we've got a segment that's secant from X to V. We've got another one here from X to Z. Got another secant there from J to L. And we have some chords. Now remember, chords are segments whose endpoints are on the circle. So W to V, that's a chord. Y to Z is another chord. And then K to L is a chord. So these theorems that we're looking at here on the page are going to be related to specifically tangents, secants, and chords. All right, the first one. If two secant segments share the same endpoint outside a circle. So we have two secants that both share point X as an endpoint. Then the product of the length of one secant segment and the length of its external segment equals the product of the length of the other secant segment and the length of its external segment. All right, so let's work with this kind of broken apart into different parts. Let's see. The product, so that tells me I'm going to multiply, of the length of one secant segment and its external segment. So one secant segment and its external. I'm going to use this secant segment from X to V. So the secant segment times the external portion. So the secant segment is from X all the way to V. I need to multiply that by the length of its external segment. Now the external, if you think about what external means, that means outside. So the external part of that same segment would be XW. So it's the whole segment times the external part is equal to, now we do the same thing for the other one. There again, it's a product of the length of the other secant segment and its external segment. Okay, so the other secant segment from X to Z times its external segment, X to Y, the part outside of the circle. So we get the whole secant times the outside part. Whole secant times the outside part. And that becomes how we're going to work with two secants that have one endpoint in common outside the circle. Okay, let's look at the second one. If a secant segment and a tangent segment share an endpoint outside a circle. So here our tangent has an endpoint of J, and J is also the endpoint of the secant. Then the product of the length of the secant segment and the length of its external segment, notice that's the same wording we had up above, the product of the secant segment and its external segment equals the square of the length of the tangent segment. So let's deal with this secant first. We take the secant segment, the whole thing, times the length of its external. So the whole thing from J to L, that length times its external part, JK. Just like what we did up above. The whole thing times the outside part, the whole thing times the outside part. Equals, now let's deal with this other part. The square of the length of the tangent segment. So we're taking whatever this length is and squaring it, multiplying it by itself. So here our tangent segment is JM, whatever that length is, squared. So for secants, we take the entire secant times the outside part. The entire secant times the outside part. The entire secant times the outside part. It's what the same process is every time we work with a secant. For a tangent, we square it. Now those are your two basic rules. So here where I see two secants, I know I'm going to take the whole times the outside equals the whole times the outside. When I see a secant with a tangent, I do the whole times the outside for the secant and then square the tangent. So with that in mind, let's look at a couple of examples that we have here at the bottom of the page. Diagrams, of course, are not drawn to scale. These are just estimates. Assume that lines that appear tangent are tangent. Find the value of x in each diagram below. So in the first diagram, I see two secants. And I know that with a secant, I multiply the entire length times the outside part. So as I'm looking here at, I'm going to look at this one first. The entire length would go all the way across. So 11 plus 10, the entire length there is 21. So the entire length is the sum of these two added together. So the outside, or the entire length times the outside part. The outside part is 11. Equals, now let's deal with the other secant. The entire length in this case has to go from this 12 and all the way to the other end of the x. Here we added these two parts together. 11 plus 10 produced the 21. In this case, 12 plus x, I can't simplify that at all, so I'm going to leave it as a 12 plus x. So I take the length of the entire secant times the outside part, and the outside part in this case is 12. And by outside, remember we're talking about outside the circle. All right, now be cautious on problems of this type. When you multiply by 12 on this right side, you have to distribute that 12. And that'll be one of the most common mistakes that people make, is forgetting to distribute that 12 to both parts of this sum. All right, so on the left side first, we have 21 times 11, which gives us a value of 231, equals, distributing on the right, 12 times 12 is 144, plus 12 times x. All right, so to solve for x, I want to subtract 144 from both sides. It's going to give us 87 equals 12x. And then I want to divide by 12 on both sides. So we end up with 7.25 equals x. Now the nice thing about these problems is that you can determine if your answer is correct by substituting it back in there. So if x is 7.25, then this entire length, when I add 12 to that, gives it a length of 19.25. So if I look here on this right side, is 19.25 the whole length times 12, 19.25 times the outside part 12, gives me a value of 231, which is the same product that I got here, so my value of x is correct. So with a secant, we take the whole length times the outside part. Whole length times the outside part. In part B, we've got a tangent and a secant. So let's deal with that secant first. We need the whole length, add those two parts together. So in this case, 4 plus 3x plus 8 becomes 3x plus 12. So for that secant, we take the whole length times the outside part. The whole length, 3x plus 12, times the outside part, 4, equals. With a tangent, we take the length and square it. So in this case, the length of the tangent is 10 squared. All right, there again, we need to distribute properly on the left side. So 3x times 4 gives us 12x, plus 12 times 4, which is 48. Equals 10 squared, or 100. All right, so we're going to take 100 and subtract 48 from it to get 12x equals 52. Divide both sides by 12, and x becomes 4.3 repeating. Now, in terms of that answer, you may either leave it as 4.3 repeating. If the problem asks you to round, go ahead and do that. You could also, if you recognize 0.3 repeating as the fractional equivalent of 1/3, you could leave it that way. Either one of those is fine. We could do it improper and leave it as 13/3 as well. So either of these two answers would be acceptable. So in general, a secant is the whole length times the outside part, and a tangent gets squared. And that takes care of tangents, secants, and chords.